Today. We're on vectors. We're on a particular group of vectors or a particular property of vectors called the dot product. And that's kind of the theme. Of course, two people arrived when I said that. Well, let's try and imagine two vectors in 3D space. So you can imagine you being like sticking out the board or something. And have a different color. And let's have the other vector here, maybe even make it longer looking, just not unusual. So, I mean, these are 3D vectors, right? I think we're shooting out any old angle you like, right? Now, one of the things that would be interesting to know would be the angle between the two vectors. And that angle there. And this angle theta can be, in some questions, in degrees. And it can also be in radians. Now, when we do calculus, you could pretty much guarantee the answers for anything to do with degrees is in radians. But vectors are kind of a special case. They're not calculus. They are things involving the three-dimensional world. And degrees are very much more practical. I mean, if you're talking to an engineer or someone who's building something and you tell them you want the angle to be 42 degrees, they kind of know what you're talking about. If you say, I want it to be 1.234 radians, you're probably going to have a problem because I'm not sure they know what that looks like, right? We all have a visual idea. If I say 110 degrees, pretty big, right? If I say 10 degrees, pretty small. If I say 1.5 radians, is that big or is that small? Not so obvious anymore, right? So if the question says degrees, then you know you want degrees. If the question says radians, then you know you want radians. So I don't think that's particularly a big issue. Let's suppose the vector u is going to be called u1, u2, u3. And let's have the vector v. I'm going to call this guy v1, v2, and v3. Then there are two different formulas that can be used to calculate what's called the dot product. And this thing called the dot product is eventually going to lead us to finding that angle, but not right now. That comes later. Right now, we're just going to focus on calculating the value of a thing called the dot product of u and v. And here are your two formulas. The first one, and you read that out as u dot v, most people do anyway, right? The dot product, u dot v. And it is u1, v1, add u2, v2, add u3, v3. Yeah, it kind of makes sense why it's called a product, doesn't it? Things being multiplied and then you add them together. This answer, isn't this a single number? It's not a vector, isn't it 42 or 0 or minus 10? We have a name in vectors for when it's a number. We call these things scalar. That makes sense, just a name. So the dot product is a scalar thing, right? It gives you a number. And if you go hunting for dot product, you might find in other textbooks or other places that it's sometimes also called the scalar product. So if you think about it, that name kind of makes sense as well. And the dot product, because there's a blinking dot there, and the scalar product, because the answer is a scalar, right? So whichever, I'll be using dot product because that's the one the textbook that we're using is using. But be aware that if you go looking for YouTube videos on the topic, that you might look up scalar product as a backup term. So far so good. Let's put some numbers on this, just made up numbers. let's suppose this guy is 1, 2, 3, and this guy is 4, negative 1, 5. Then if you wanted this dot product, you would go 1 times 4, add 2 times negative 1, add 3 times 5. This would be 4, take away 2, add 15, and your dot product of the vectors u and v, u dot v, would be the number 17. Okay, let's talk big pictures here. Could the dot product end up being a negative number? Could you imagine a situation where you could get a negative dot product? Agreed? Good on. Definitely a positive, right? We've just seen one. Could you, in very special circumstances, couldn't you get a dot product equal to 0? Now, those three situations do tell us a little bit, not a lot, but a little bit about the angle between the two vectors, right? About this fellow here. If the dot product is positive, then the angle theta is acute. Does anybody remember what acute angles are? What's special about them?
Less than 90.
So, less than 90 degrees. And if the dot product is a negative number, like you get it and it's negative 10, whatever, then theta is obtuse. And that means bigger than 90. Right, exactly. And there's one more guy you squeeze in. If I planned it, I might be able to squeeze it in here. And the third situation is it could be 0, right? So you could do the dot product and the answer is 0. What do you think that might tell us about the angle theta?
That it's 180 degrees.
What number?
I think 180 degrees. Or multiples of it.
Wind that number down a little bit and you're in the right place. Not 180.
90.
Yes. So if I can wonder, 180 is not a silly answer. I can understand why you might think that. But in fact, if the dot product is 0, then the angle is 90 degrees. It's right angled, various other names. Now I could convert them into radians, but it's the same information. So right now I can't tell you, except maybe with this one special case, what the angle between the two vectors is. But at least I could tell you if it's bigger than 90 or less than 90. If the dot product is positive, it's less than 90. And if the dot product is negative, it's greater than 90. That's helpful. Now, I said there were two versions of calculating the dot product. Here is version number 2 now. U dot v, length of u, length of v, cosine of theta. If you were doing a question like this, the information about the vectors u and v would not be, I'll tell you their components. What you would get instead would be something like this. I won't tell you what u and v are in this form. I'll just tell you that the vector u is, say, 5 units long, and that the vector 3 is, say, 3 units long, and that the angle between them, and I could give you in 30 degrees, and they do, but let's suppose I just decide that sometimes they'll give you the angle in radians, so in this case it would be. You can tell when an angle is radians, don't they tend to be multiples of pi, 2/3 pi, half pi. If you see a pi in it, it's pretty much it. If they have a little circle on it, 14 degrees, you kind of know it's degrees. So in this world, the dot product would be the lengthy vector u times the lengthy vector v times the cosine of theta. In this case, it would be 5 times 3 times the cosine of pi over 4. Those two get me 15, and that guy gets you root 2 over 2. And pretty much, there's your dot product. So right now, we're just focusing on calculating the dot product. Right, if they give me the dot product, if they give me the two vectors in terms of their components, then use this formula here to get the dot product. If they tell me the information about the vectors in terms of their magnitude, how big they are, and the angle between them, then use this formula to get the dot product. Are we comfortable about how you can get the dot product in two different ways, depending on what information they give you about U and V? Okay. So let's give you a puzzle one. Try to find this guy out because it is a copy of a question. Here we go. Here's U going this way. Here's V going this way. We are told that U and V are unit vectors. We're also told this guy here, which I'm not going to use right now, is W. And it's also a unit vector. And here's your question. Find the dot product U dot V. The way this information is given, if you tell me that it's a unit vector, haven't you basically told me that the magnitude of U and V is 1? Right? That's what a unit vector means. And this question looks like we're in trouble. Because that's clearly the formula I'm going to use, but something's missing. I know that's one. I know that's one. What's missing is I also need to know the angle theta. Yet they didn't say theta was 20 degrees or theta was pi upon 4. They never mentioned theta at all. They're being sneaky here. And by the way, theta would be the angle between those two vectors. If you have two vectors pointing away from a point, then the angle theta is the angle between them, right? What is the size of theta? Because I actually do know it.
60 degrees.
Correct. How do you know that?
Because it's an equilateral triangle.
Okay. The radian folk amongst you would have written that, agreed, but it's the same thing, all right? What is the exact value for the cosine of 60 or the cosine of pi upon 3?
1/2.
Oh, I was going to show you in the calculator, but yeah. Do you know about half of standard angles, the nice ones at least, can't you get the calculator? But hopefully you know that anyway. So it's a half. So what do I get? 1 times 1 times a half, and the answer is a half. So find the dot product. That's question 1, or question A, I guess, from 6. So that's question 6A. 6B is sneaky. I'll tell you what the answer's not. It's not a half. And you probably think it should be, and I understand why you would. We're going to get it the same way. But the angle, oh, by the way, a little visual. That angle in there is 60 degrees. So is that 60, and that's 60, right? Well, the length of U is 1. The length of W is 1. But the angle is not 60 degrees. You need two vectors meeting a point, leaving that point, and the angle theta is measured in that way.
It's 120, right?
It is 120. Do you see the little sneaky blighters? Didn't give you clues. If I continue this guy going this way, wouldn't this one here also be U? But won't the angle that we need be 120? Whoops. Are you happy about where that 120 came from and why it was a bit sneaky? So that's going to be 1 times 1. What's the cosine of 120?
-half.
You would think it could be, because sometimes one's plus and one's minus, but all sine times cos, that sounds about right, doesn't it? Right. Agreed. Second quadrant, shouldn't a cosine be negative in the second quadrant? Right, all sine times cos. And so there's your answer. So right now we are just finding dot products, right? And this particular one is using the formula magnitude of U times magnitude of V cosine theta, or in this case U and W, but same formula. So far, so good.
Can you explain again why we used 120 degrees instead of 60?
Right. If you imagine the vector U and the vector W, it's those two pens. You need to start at a fixed point, and W leaves this way, and U has to go this way. They have to leave at the same point and go outwards, and this is the angle theta.
Okay.
But if you look, U's going here on this picture. What you have to
Yeah.
imagine is bringing it down to here to match up with that one.
So we find the degree based on where both of the points meet and then where they go out.
Correct.
Okay, thank you.
Right. That makes sense? Right. Totally different question, different triangle. But can you imagine that there was a triangle where this guy here was 45 degrees, right? This is W going this way, and this is U going this way. If I wanted to do U and W, wouldn't I have to use this angle? You need to be at a fixed point, and both vectors need to leave that fixed point. Oh, which would make that what, 135 degrees. Right. So it's just another situation like that. Good to move on if we are good to move on. Right. Let's look at dot products where you're told components, because in a lot of ways aren't they much easier to do, because what you need is in front of you, right? You don't need to go hunting for it. So let me see if I can find one. Okay, here are some examples similar to 3 and 4, but I'm not going to choose the same fellas. Suppose this guy is 1, 1, -7, and this guy is 2, 3, 1. Then if you want to get the dot product, you go 1 times 2 plus 1 times 3 plus -7 times 1, and 2 odd 3 take away 7. I believe the answer is -2. I mean, if you just tell me the components, isn't the dot product just plug and chug, right? There's not an awful lot of thinking about what to do. Suppose I give you the information about U and V in a different format.
So is that top vector W or U?
Oh, okay, I'll make that W. now it's consistent. Sometimes they use IJK notation. It doesn't change really anything vital, but you have to be a little bit more careful. 2 times 2 plus, oh, be careful. -3 times what?
0?
Yeah. And then 4 times 1. So you get a 4. Well, it doesn't matter. Nothing. Add another 4. So the answer is 8. I find, for me, doesn't need to be true for you, that if I write these guys down in this format, that I'm less likely to screw up who the zeros are and who isn't. Can you see now it's 2, 2, -3, 0, 4, 1, right? And I don't have the issue of, because not that you've ever seen me do it, but occasionally I do make mistakes. And so if you know your own weaknesses and you know ways to try and combat them, and for me, that's one of the ways I use to combat silly mistakes I can make, we got our answer. I don't know the angle between U and V, but I do know its dot product is 8. What does that tell me about the angle?
It's acute.
Yeah, some between nothing and 90. What about the angle between these two, U and W? That's what I've decided to call them now.
Obtuse.
Right. Wouldn't it be nice if we could do better than that? Which we will, but not yet. Let's look at component form, but just a little bit uglier. Let's see if I can find an ugly one. Oh, here's one. I was beginning to give up hope. We get two vectors, -41, b, and 5. And the other vector is b, b squared, and b. And I would like to know, call this U, I'll call this V. I'd like to know the dot product. Now, as long as I apply the formula, I'll get an answer. Would you agree that the chances are that this answer will not be a number like 42? Won't it be an expression with some b's and b squares and who knows, right? That would be my gut feeling. So let's see what we get. -41 times b, add b times b squared, add 5 times b. -41b, add a b cubed, add a 5b. These can combine a little bit. And what do you get? You get b cubed, take away 36b. So far, so good. Are we comfortable with the dot product just being an expression with B's? Let's take this a little bit further. I want you to do style points on that. Any idea what I could do to make it look prettier?
Factor out a B.
A B.
I would do that. Can I factor b squared minus 36 to make it even prettier? B squared minus 36 can be factored.
B plus 6 times B minus 6.
Do you recognize the difference of two squares? No, it's the same thing, it's the same answer, but it looks prettier. Why is this version going to be nice? If the dot product is 0, what do we know about the angle between the two vectors?
It's 90.
So that must mean then that there's only certain values of b where these two vectors will end up being 90 degrees apart. And there are only 3 values of b that will be true. If b is equal to 6, won't this be 0? And so they'll be at right angles. If b is equal to negative 6, it'll be 0. And if b equals 0, it will be 0. So these two vectors, although they're quite variable, right? You could pick any number in the universe for b, wouldn't you? You get two vectors, or u and a v out of it, right? But out of all the permutations in the world, there's only 3 of them where these two vectors end up being 90 degrees. And if I plug b equals 0, let's see what the first one looks like. Negative 41, 0, 5, that would be the u vector. And the v vector would be 0, 0, 0. Interesting result. Negative 6 would give me negative 41, negative 6, 5, and negative 6, positive 36, negative 6. Interesting. And then 6 would give me negative 41, 6, and 5, and 6, 36, and 6. Now, in these two situations here, would you agree that you get two physical vectors, right? Two vectors that really would be right angled, right? Like this. This fella here is a bit of an anomaly. Isn't the second one the 0 vector? And I've not mentioned it, so I'm now going to mention it right now. If the dot product is 0, the angle between the two vectors could be 90 degrees, which is what these two are doing. But couldn't it also mean u and or v is the 0 vector? So if you're being lawyer-esque about it, the dot product between two vectors equals 0 means that the two vectors are at right angles, right? Or that at least one of them is a 0 vector. Well, we assume, for common sense purposes, that it wouldn't be a very sensible world if you started using 0 vectors and talking about angles between them. Would you agree it wouldn't really make sense? Because isn't the 0 vector just a dot in space? And what's the angle between a dot in space and a real vector? Well, I'm not quite sure it has any meaning. So, yeah, that is true, but we wouldn't use that as a usable solution. So if the question was, for what values of b do you end up with two vectors that are 90 degrees, right, are at right angles, these two would be the ones that work. It's kind of interesting little puzzle. Now to tell you how to find the exact answer, or at least rounded off answer, because most of these answers end up being 22.1 degrees, right? They don't come out nice. Let's find the answer to the angle between two vectors. And I want to show you that this works no matter what the two vectors are, as long as there's no zero vectors involved, which there won't be. Okay. Who am I picking? Noah, give me the components of vector u. Give me the three numbers that I'm going to use.
-5, 10, and 7.
Okay. And I'm going to pick 1, 2, 3 because I'm lazy, right? And I didn't pick 1, 2, 3 so something nice would happen. It totally was just random, right? Now, if you want to do this fella here, I have to tell you the formula for doing it. The angle between, oops, an E, between two vectors, we'll call them U and V, is found by using this formula. The cosine of that angle, right? The angle theta that you're after. It's the dot product of the two vectors divided by the magnitude of u times the magnitude of v. And typically in these questions, you're going to be given the components. So I'll switch places now. And we'll look at, oops, how to use this formula. Well, I need to know the magnitude of u. So that's going to be -5 squared plus 10 squared plus 7 squared. That's 125 and 49. I'm not risking it. 125, add 49. I get the square root of 174. You do not need to worry about making that pretty, right? It might simplify, it might not, doesn't matter. The formula doesn't really care. This one is going to be 1 squared plus 2 squared plus 3 squared, which I believe is the square root of 14. I then find the dot product. So -5 times 1, add 10 times 2, add 7 times 3, and that gets me 5 and 21, so I believe you get 26. Are you all comfortable with the numbers that I've got right now? If I made a mistake, tell me. Do those three guys look good? Magnitude of u, magnitude of v, and the component version of the dot product. Okay, now you put the packet. Question?
Sorry. Isn't the dot product, I think, shouldn't it be 36?
I don't know. Could screw up here. Agreed. Now we're good. Right, now, cosine of theta is the dot product divided by the magnitude of u times the magnitude of v. In this case, 36 square root 174 times square root of 14. What do you need to do to get from the cosine of theta equals this ugly guy to theta?
Take the inverse cosine of both.
Right. So you're going to find the inverse cosine of this ugly guy. which is why you're almost always going to get ugly answers and to one decimal place or to the nearest whole number. This fella involves the calculator. Obviously, I'm not going to do that in my head. And I have to be careful here. We will assume that the answer will be in degrees unless the question tells you otherwise, right? So if the question says, I want it in radians, do it. If the question just says, find the missing angle, we will assume that they mean in degrees, because in many practical ways, degrees just make more sense to human beings. Now, here is my first mistake. Inverse cosine of 36 divided by the square root of 174 times the square root of 14. Ooh. Didn't like that answer. I don't know if I can. There. Do you see anything wrong with the way that that question has been written down? Because it does look like it's okay, but it's not.
I think you're missing a parenthesis in the beginning.
Okay, let's see if I can fix the parenthesis then. So I should insert a parenthesis, right? Does that look okay now? Nope.
No, you should have one in front of the square root, in case in both square roots.
Put the parenthesis before the first square root.
Right. So this bit here needs to be written down. So I'll write this down and I'll do it in a calculator. As 36, right, divided by, put a bracket round the two guys, which I'm assuming that's what you were asking me to do, right? And that's getting closer, but it's still not going to be right. But this last mistake,
Doesn't like a square root in the denominator.
no. There's your answer. But it's still wrong. I want the answer to be in degrees. What do you think I'm looking at?
Radians.
Right.
Do you need to go in the
How
mode?
many? Yeah. How many times have you had your calculator in degrees when it should be radians, or radians when it should be in degrees? I mean, it's, you don't even think about it. But isn't that 0.75 degrees kind of small? It should be a kind of worry. So if I now go to mode and I set it up in degrees, I should be able to do it one more time. And the right answer is what? About 43 degrees. So when you are doing this darn question, make sure it's inverse cosine. Everybody's not going to screw up there. Bracket, the top guy divided by another bracket, the two square roots, close a lot of brackets, and always be on the lookout for, do you want radians? Do you want degrees? And we're assuming that everything is degrees, unless, you know, otherwise. Now in calculus, isn't that the other way around? Don't you assume everything is in radians unless they tell you degrees? I don't even know if you've ever seen a calculus question with degrees in it. If you did, it's very rare, right? So, well, I think 43 degrees makes sense. Do you agree that two vectors 43 degrees apart? Yeah, that could happen. Do you think 0.75 degrees could happen, but shouldn't it worry you? It looks a bit in the small side. I think that went pretty smooth. You agree? Okay, I laboured this point, but the reason I'm labouring this point is you do everything right and then you hit the wrong buttons on your calculator, right? You miss a bracket where you should have one. You go in radians when you should go in degrees, and it'll frustrate the heck out of you because it's not that hard a question, would you agree, up to here. And if you don't get it right, you're just going to think, well, I'm not doing this right, or you're going to look in the wrong place for the mistake, right? The mistake is probably going to happen at the calculator side most of the time, except for me who can't count. Right. Are we good? Let's look, I'll look around for another one. I'll just make up my own, it's quicker, because they're easy to make up anyway. And the question is, find the angle between these two vectors. And I would find this guy. I would find this guy. And I'd find this guy, right? I'm going to find this guy first. Oh, make this -2. Yeah, that's more interesting. Yeah. And this guy is 0. Can't I short circuit the entire question now? What is the angle between these two vectors?
$90.
Would you agree that when the dot product is 0, you get 90 degrees, except in that lawyer-esque situation where one of these is a 0 vector? Well, neither of them are 0. And we are good. Terminology for you. 90 degrees, correct. Couldn't we say the two vectors are right angled, right? Here's the word that you'll find a lot. We say that the two vectors are orthogonal. So theta equals 90 degrees means right angled to us, but it's also the word orthogonal. And you might think, why did we need one more word when right angled works? Can you imagine you move to fourth dimensional vectors, 4D vectors? Couldn't you get a dot product for 4D vectors? Right? It wouldn't be hard to expand the formula. And it could be 0. So what does that mean? Does it mean that the two fourth dimensional vectors are at right angles to each other? And does that term even make sense? So we just say the word orthogonal. And that's a better picture, right? Orthogonal. I don't know what right angled looks like in fourth dimension. I'm not even sure anybody knows what it means. But don't we now have a label called orthogonal, which takes us away from having to worry about what it is because we got a name for it. Here's another one. This is a special case as well. Do you notice that these two vectors are multiples of each other? Right, isn't the second one just 3 times the first one? Now, before we do the working here, let's see what that's going to look like. If you can imagine this being the vector u, and then won't the vector v just be like 3 times bigger, if you imagine that's 3 times bigger? What's going to be the angle between these two vectors? Well, if you do the vector u like this, and then on top of it, you put the vector v like this, would you agree that the angle should be 0? It's a bit like me saying, oops, what's the angle between these two vectors? Well, if you're on top of each other, is it an angle between them 0? Let's see what our formula makes of that. The magnitude of u is 1 plus 4 plus 16, which is what, square root of 21. The magnitude of v is 9, add 36, add 144, which is 160. Is that 169? No, it's not.
189.
189. Okay. 189. U dot V is going to be 1 times 3 plus 2 times 6 times 4 times 12, which is going to be 3 add 12 add 48, which I believe is 63. So the cosine of theta, which is the dot product divided by the magnitudes, is going to be 63 divided by those two ugly guys, and theta is going to be the inverse cosine of 63 divided by those two guys. I want to get 0. Agreed? That's what we should get. Let's see what we have then. Inverse cosine. 63 divided by a bracket, square root of 21 times square root of 189. Yep. I think you have 2. If I made a mistake there, I'll fix it. Oh, 0. Doesn't that exactly match our prediction? Now, if you know that one vector is a positive multiple of the other, couldn't you just jump to the answer 0 degrees and save yourself a whole load of work? If you have 2 vectors and they're not 0 vectors, but you know because you've looked ahead and you found that the dot product is 0, can't you jump straight ahead to 90 degrees orthogonal? Right. Third possibility, only have time to talk about it. Suppose U and V are those two guys. Now, they look almost identical, right, to this story, but there is a difference. Isn't U going this way and V going that way? So when you put them together, won't the angle be 180 degrees, not 0? Does that make sense? That if you are a negative multiple of the other guy, the angle between you will not be 0. It'll be the extreme opposite of that. It will be 180. But can't you use all those answers in reverse? Suppose I have 2 vectors and the angle between them is 0. Does it not make them parallel? If you're multiples of each other, aren't you also parallel? If the angle is 90 degrees, does it not make it orthogonal? If the angle is 180 degrees, does it not mean that you're kind of parallel, but pointing the wrong directions from each other, right? Pointing away from each other, rather than parallel pointing in the same direction as each other. And that is all for today. And pretty much perfect timing, exactly on the dot. So say hi before you go, and I will hang about for homework questions and any other questions you may have. So, bye-bye.
I have a quick question on how did you paste what you already wrote in your calculator?
Oh, that little trick. Yeah.
Yeah.
Let me swing back and show you that. Right, there's a little button here called enter, and above it in blue it says entry, right?
Oh yeah.
So if you hit blue button entry, it will bring up the last calculation.
Oh, nice. Okay.
Okay.
Thanks. Yeah.
Oh, nice little thing, you know. Sam, any other questions, Douglas or Sam?
I do not
Um.
have a question.
Oh, what?
I don't have a question.
So what if the distance, like the denominator is 0?
Well, the only way the denominator is going to be 0 is if u or v are the 0 vector.
Oh, and then you would already
And
know.
then we wouldn't be using this formula anyway because it wouldn't make sense. So
Okay.
if either of them is a 0 vector, it's not really a dot product question, is it? They shouldn't really put a 0 vector in those questions because it makes no sense.
Yeah. Okay, I see. So just like a recap. So if two vectors are a negative multiple of each other, the angle is 180 degrees.
Correct.
And if you know that two vectors are multiples of each other, then it's 90 degrees. And if you know that
No. If you know that two vectors are positive multiples of each other,
yeah.
the angle is 0 degrees. So visually, if you have a u going this way and a v going the same way, that's a positive multiple. The angle will be 0 degrees. If you have a u going this way and a v going that way, because they're negative multiples of each other, you'll get 180 degrees. And if you have a u going this way and a v going that way, and the dot product is 0, then you're looking at 90 degrees.
If you know the dot product is 0, then you know it's 90 degrees. Theta is 90 degrees.
Yeah.
So you're not plugging in. So this is the answer, right? You don't plug this into the inverse cosine.
No, this is the answer you'd get after you did all the inverse
Okay.
cosine stuff.
Okay.
So you'd either get 0, 180, or 90. We'll just pretend that 0 vectors don't exist because they're not going to happen in the question. So when you plug it in, you're going to get a number somewhere between 0 and 180. Why can't you get an angle bigger than 180? Never talked about that, but why wouldn't two vectors have an angle bigger than 180 between them?
Is it because we're always just looking for the closest distance rather than the biggest?
Yeah. If you had two vectors and you said, oh, that's 300 degrees,
Oh yeah.
well, the angle between them 60 anyway.
Yeah. I
So
see.
as they bend apart, isn't the furthest apart they can get is a 180? And if they go any further than 180, won't the closest angle be this one, not that one?
Right.
And this is the angle you always get from the formula, right? So it's kind of clever that it does that. Another thing that's kind of clever about this formula is you don't need to worry about which quadrant the angle's in, should you make things positive or negative. You know, some of the trig issues that you might have had. Inverse cosine, you're done. If it's the second quadrant, you'll find out because the answer will be 99. If it's in the first quadrant, you'll find out because it's 15, right?
Nice.
And even the two extremes come out. So the formula is pretty versatile. If you just do it and trust the math, it'll give you